This is a lesson on nonlinear inequalities, section 2.6. If you could turn to your class notes, page 15. Let me briefly talk about linear inequalities that you learned back in Algebra 1. If you have a linear inequality, you just need to solve it just like a linear equation, except when you divide or multiply by a negative number, then you're going to change the inequality. So the greater than will become less than, and less than will become greater than. Okay, today we're going to be looking at polynomial inequalities. So that would be a degree of 2 or greater, as well as rational expressions of p of x divided by q of x. There's 5 steps in solving polynomial and rational inequalities algebraically. The first is to write the inequality so that a polynomial or rational expression f is on the left side and the 0 is on the right side. And it's going to end up to be one of the following forms. You can have f of x greater than 0, f of x greater than or equal to 0, f of x less than 0, or f of x less than or equal to 0. The second step is to factor and determine the numbers at which the expression f on the left side either equals 0, and if the expression is irrational, the numbers at which the expression f is undefined. So if it is equal to 0, then you'll be setting the denominator or the numerator equal to 0. And if it's undefined, then you'll be setting the denominator equal to 0. These are called critical numbers, and I'm going to abbreviate it as CN in the problems. The third step is to use the numbers found in step 2, those are the critical numbers, to separate the real number line into intervals. The fourth step is select a test number in each interval and then substitute this number into the factored expression. And you're going to determine the sign of f at the test number. You do not need to find the exact answer. So the sign will either be a positive or a negative. So there will be 3 things that you have to look for. First, if the value of f is positive, then f of x greater than 0 for all numbers x is in the interval. If the value of f is negative, then f of x is less than 0 for all real numbers x in that interval. You'll include the zeros for less than or equal to or greater than or equal to in the solutions of f of x is equal to 0 in the solution set. Write your answer in interval notations, and you'll be using parentheses for less than or greater than, and brackets for less than or equal to or greater than or equal to. And it is possible to have combinations. So you could have a parentheses and bracket or bracket and parentheses. For negative infinity or infinity, you always use parentheses. Okay, let's go to our first example. Okay, so the first step is actually already done for you in this. The function x squared plus 8x is already placed on the left side, and the right side is 0. So I'm going to fully factor x squared plus 8x, so that will be x times the quantity x plus 8, and is greater than 0. So I look at where this is equal to 0, so I'm finding my critical numbers, and that would occur at x is equal to 0, and x plus 8 is equal to 0, so x is equal to negative 8. So my critical numbers are at 0 and negative 8. So I've gone through the second step. The third step is to draw a number line, and I'm going to put in my critical numbers of a negative 8 and 0, and then I'm going to do my test number line. Okay, so if I choose a number to the left of -8, and you can just go the next integer over. So at -9, I put the -9 back into the factored form. So negative and then -9 plus 8 will give us another negative. So negative times a negative gives us a positive. So in this particular interval, it's going to be positive. And then in between -8 and 0, if I choose, say, a -1, I'll have a negative and a positive. So overall, that's going to be a negative. And then to the right of 0, I'll choose 1. That will give me a positive and a positive. So overall, that's a positive. So since the inequality that I'm looking for is greater than 0, I want to choose the interval where it is positive. So that would be this region, so I've just highlighted in red, along with this region right here. And then since it doesn't say equal to, I don't want to include the critical numbers, so I'm going to be using parentheses and parentheses here. So my answer in interval notation is -infinity to -8, and it's parentheses here, union, parentheses, 0 out to infinity. Now on your graphing calculator, I'm going to graph the left side as y1. So I'll be putting in x squared plus 8x into my calculator. And then on the right side, I'll call that as a y2 of 0. So you should darken the y2, just make it as a fat line. And then here's my graph. I just sketched it out. So here is my y1, the blue one. And then my y2 is the red one. So I can figure out what my critical numbers are by looking at the intersection of the two graphs. So this right here, the intersection would be at a -8, and this intersection is at 0. So I want to know, where is y1 greater than y2? So where is the blue graph above the red graph? So in this particular region, blue is above the red. If I just put my pencil here and line it up, I can see that the y value in y1 is greater than y2. So this is the true region. And then this is all false. So between a -8 and 0 is false. And then from 0 out to infinity is also true. So that's just justifying the answer that I found algebraically. So this is just a graphical representation of the answer that I have up here. Okay, let's look at the second example. So for the second example, I'm going to shift over the -12, and so it'll be x squared plus 7x plus 12 is less than or equal to 0. I factor this as x plus 4, x plus 3, and that's less than or equal to 0. So my critical numbers are x equals -4 and -3. So I put my number line and put in the critical numbers of a -4 and a -3, and then I'm going to test the numbers out. So when I put in a -5 into this factored form here, I get a positive overall. Now, -3 or -4 to -3, I have to choose a fraction, so I'll choose a -3.5, and in that region, if I plug it back in here, I get a negative, and then greater than a -3, I'll get a positive. So I look at my inequality, and I want it less than 0, so then I'll choose my negative numbers. So it's going to be this region right here. And since it says equals, I'll be using both the critical numbers. So it's going to be bracket -4 to -3 bracket. Okay, for the graph, I have y1 on the left side is x squared plus 7x, and y2 is a -12. So y1 is the blue graph, and then y2 is the y2 is -12 is the red graph. And so I want to know, where is the blue, so I've just color coded this so that it's easier to read. Where is the blue less than or equal to 0? So then that would be in this particular region right here. This is section 9.5, and we'll be continuing. Okay, so that would be the graph for it, and then that just justifies what I have right here. Okay, let's do one more example on the next page. All right, for the next one, I have this expression, and then on the other side, I have a negative 9, so I need to bring over the negative 9 as a positive 9, and I get 4x squared minus 6x plus 9 is greater than or equal to 0. And when I try to factor this, it is not factorable. So I'm going to check with the discriminant. Remember, for the quadratic theorem, you have square root of b squared minus 4ac as the part that is under the radical. And so when I put in the b squared minus 4ac, b being a negative 6, and then a is 4, and c is 9. So when I test out the b squared minus 4ac, I get 36 minus 4 times 9, which is less than 0, which means that the radicand is a negative, which will give me an imaginary number. So that means that there are no zeros, so the entire graph is above the x-axis. And if I look at this graph, I know that this is a parabola and it is going upward. So if there are no zeros, then it's never going to go down and cross the x-axis. So my solution set here would be from negative infinity to infinity. On my graph, I'm going to put in the left side as my red graph, and then the right side is negative 9, so that will be a y2. And so if I look at this, I can see that in the entire region, the y1 is greater than y2, so then that verifies why the answer is a negative infinity to infinity.